Hi, this is Dr. Lewis Cady, and you are looking at me here in the exam room at Cady Wellness Institute. Currently, I have my hand on the Pharmanex Biophotonic scanner. This is the second generation model, the so-called Everest model, because it was updated actually for a scientific expedition as people climbed Everest and to measure their antioxidant levels and their oxidative stress. What I am doing right now is actually called the operator scan on the scanner, and you can see the progress bar right here as it goes. With this particular scanner, it takes 90 seconds to do this biophotonic scan, which I'll explain in a moment. Very shortly, we will have the brand new version of this, the S3, that takes only 30 seconds, and instead of this fairly large scanner and a PC computer, the entire thing will be battery operated, portable. It will communicate with just a little iPad head unit, and so there won't be any of these cords and power supplies and so forth. Now, what the biophotonic scan is a technique to measure something called a Raman shift. And the Raman shift occurs when a light beam at a particular frequency goes into something, in this case human tissue, is reflected back, and the color changes. That color change is the Raman shift. And what this device is doing, and you can, I'll ask our camera operator to zoom in a little bit, it's showing that my antioxidant score is really quite good. It's at 53,000. Now what has happened is that on this scanner there is a little blue LED right here, and it shoots a beam of light into the palm at 473 nanometers. This is reflected back into the detector at 510 nanometers, and basically those numbers mean it goes in as blue and it comes out as green. And there is the detector in here to actually count the little photons, the little green photons that come back. So blue photons go out, green photons come back, and the number of the green photons that come back by this calculation, which is done in the computer, gives you the so-called Raman shift, or the skin carotenoid score. And then this is normed, and it is reproduced on this computer and also the iPad head unit, and also these little cards, the Pharmanex scan cards that we're currently using, in red, orange, yellow, green, and blue. Now red basically means check engine light. It means there is something wrong. Your score is down so low that you are in a state of oxidative stress. Yellow is caution, orange is halfway between terrible and caution, green is good, and blue is better. It's interesting, this is actually the spectrum, and this is lower energy to higher energy. Kind of cool. So what this does is it allows us to measure where on this spectrum you are, and red is bad, F. So it's F, D, C, B, A. 53,000, that's A minus. I didn't scan too well today because I must not be taking enough of my LifePak Nano, but typically I'm around 59,000. Now, the reason that this is important is that your antioxidant level, to a large extent, is correlated with how healthy you're going to be. And if you look in the peer-reviewed medical literature, and you can at pubmed.gov, you can search on oxidative stress with, or antioxidant with, the disease or the affliction of your choice. I'm an integrated neuropsychiatrist, so I tend to focus on mental issues and disorders. There is no reference that you're going to find out there that oxidative stress is good for you with a psychiatric condition, and in fact quite the reverse. Oxidative stress is associated with ADHD, autism, bipolar, depression, schizophrenia, and pretty much, if it's bad for you in psychiatry, Alzheimer's disease, neurodegenerative diseases. If it's bad for you in psychiatry, it's associated with oxidative stress or a poor antioxidant level. Now, it's important to note that this is a skin carotenoid detector. You can't say it specifically measures every antioxidant in the body, but studies show that the score that you get here, the carotenoid score, is basically highly correlated with the oxidative stress state of your body. In general medical practice, family medicine, internal medicine, again, you think about everything that could possibly go wrong. Joint pain, fibromyalgia, heart disease, cancer, breast, prostate, stomach, particularly skin, anything that is associated with oxidative stress is an exacerbating influence on medical conditions. So I thought what I would do now is do kind of a Mr. Wizard science experiment version of Raman spectroscopy. Now what I have here is a Browning camo, you'll note, a Browning camo flashlight that one of my patients brought to me, one of my patients' parents, because on one occasion I was missing my diagnostic pen light. And this is a really nice bright one, as you can see, but it's a hunting flashlight, and so there are two other colors. There's a red color and there's a blue color. Now if you're a hunter, or if you do things outside, the red color is very helpful for preserving your night vision. The blue color is actually Raman spectroscopy live and in person while you are out hunting. If you have shot game and you are trying to track it, because hemoglobin, the oxygen-carrying molecule in the blood, actually, and I wrote my statistics down here, actually absorbs light in the 410 to 420 nanometer range, that's blue, and it transmits it strongly in the red, 680 to 690 nanometers. So what happens is when you are tracking game that has been shot and is bleeding, and you are looking on the ground in the dark, and speaking of in the dark, let's go ahead and start killing some of these lights here. In the dark, and I'll just keep talking, you're searching in the dark for the blood. The hemoglobin in the blood actually picks up the light, absorbs it, and reflects it back as a brighter red. Now we're not hunting game, so I thought I would show you a quick example of how this actually works with Raman spectroscopy. So what I have here is I have a little yellow filter, and I have a packet of earbuds. I think these are for one of my Bluetooth headsets, and it's a reflective backing. So what I'm going to do is I'm going to take the blue LED light and I'm going to shine it through this yellow filter, and the yellow filter is absorbing some of the light energy, and then we're going to see how it reflects back. And if you look at it right here, let me see if I can get this focused. Right there. You can see that as the blue light goes into the filter and the filter absorbs some of the energy, just like carotenoid molecules do in the skin, and it is reflected right here. It is reflected back to the detector, which in this case is your eye. You can see that the blue light frequency has turned to green. And this is exactly how the Biophotonic scanner works. Let's go ahead and bring the lights up. So I hope that this illustration was helpful for you in understanding not only the Biophotonic scanner, but Raman spectroscopy and how it works. Thanks for joining us.